Electricity is one of the greatest technological innovations by the human race. It has now become an indispensable part of our daily life. However, a major part of the electrical energy is produced using fossil fuel, which pollutes the environment. Solar energy, which is a free, perpetual, and clean source of energy, was discovered many years back with a piece of shiny metal which can reflect sun rays. It satisfied the basic need for cooking and heating in ancient days. In modern days it is being used in many ways by converting solar energy to electrical energy with a solar panel. In this video we will discuss about the solar photovoltaic system. It is means of conversion of direct rays of sun into electricity. In the recent decade, there has been an increasing number of residences and institutes that used solar energy as a substitute power for lighting and heating. This is because solar energy is an unlimited energy resource, set to become epitome of renewable power source in the years to come. Sun's energy is tapped using solar cells which are fixed on the ground. The amount of sun's radiation received by Earth is equivalent to total energy used by whole population of the world in a year. Solar energy is actually nothing new. People have used solar power as far back in history as the 7th century BC. In its most primitive state, energy from the sun has been revered and put to use almost as long as man has walked the earth. The earliest uses of solar power included focusing the sun's energy through a magnifying glass to start fires for cooking. By the 3rd century BC, Greeks and Romans bounced sunlight off of burning mirrors to light sacred torches for religious ceremonies. Sunrooms were invented in ancient times to capture solar energy for its natural warmth. These usually south-facing rooms have captured and concentrated sunlight from the famous Roman bathhouses to Native American adobes, and are still popular today in many modern homes. Sun's radiation consists of various frequencies of electromagnetic rays ranging from infrared to ultraviolet. The yellow region if the graph shows solar radiation spectrum outside Earth's atmosphere. As sun's rays enters atmosphere, certain band of frequency is absorbed by atmospheric particles like water, carbon dioxide, and ozone. Therefore, red region represent the actual radiation spectrum received by Earth's surface. The solar cell consists of p-n junction. When light reaches the p-n junction, the light photons can easily enter in the junction through very thin p-type layer. The light energy in the form of photons supplies sufficient energy to the junction to create a number of electron-hole pairs. The electron-hole pair is created by only certain narrow band of spectrum. Frequency below this spectrum do not have enough energy to create electron-hole pair. Frequency above this spectrum do not produce useful electron-hole pair. This band of incident light breaks the thermal equilibrium condition of the junction. The free electrons in the depletion region can quickly come to the n-type side of the junction. Similarly, the holes in the depletion can quickly come to the p-type side of the junction. Once the newly created free electrons come to the n-type side, cannot further cross the junction because of barrier potential of the junction. This is how potential difference is created across the junction. On connecting external circuit connecting two material, electron will flow. There are various kinds of solar cells such as monocrystalline, polycrystalline, thin film cell, and multi-junction cells. Commercially used solar cells are monocrystalline and polycrystalline cells. This is because they are relatively cost-effective. Monocrystalline solar cell is more efficient than polycrystalline cell and cost more than polycrystalline cell. Thin film solar cells are flexible and are used in surfaces which require bending and twisting. Multi-junction solar cells are highly efficient solar cells. Its efficiency ranges from 30% to 40%. They are used in artificial satellites because they need to generate enough power from limited area. However, they are very costly. Solar energy is trapped in various means. Solar photovoltaic system. Solar thermal system. And concentrated solar thermal system. Commercial solar cell used in solar farms have efficiency ranging from 15% to 22%. The total energy generated by solar cell in the form of electricity is just 15 to 22% of total solar energy received on Earth. To boost the total energy generation of the solar cell, there are various methods employed. Maximum power point tracking system is method of obtaining maximum power from solar by maintaining maximum power point voltage of solar. The solar cell will have one particular cell voltage where maximum power is produced. This voltage is maintained by the device called Maximum Power Point Tracker, or MPPT. Another method is solar tracking system. This system ensures the solar panel is always facing direct sunlight. This is done using actuators, sensors, and control system. This is comparative graph showing solar output power versus time of the day between tracking system and static system. There are two types solar tracking system: dual axis and single axis. Dual axis tracker will track sun in east-west direction and north-south direction. Single axis will track only in east-west direction. Large solar farm usually are either static or single axis tracking system. Dual axis are rarely used because it is costly as it requires solar tracking system for individual solar array. The single-axis solar array are oriented in north-south direction, and static array are oriented in east-west direction. For instance, Benban Solar Farm in Egypt is oriented in north-south as it is single-axis tracker. Badla Solar in India is oriented as east-west as it is static. According to International Renewable Energy Agency, in just 2020 itself, the solar industry see growth of 125,800 megawatts of installed capacity. This is because of reduce in cost of solar panel as mass production of solar cell comes into play. Today, solar energy has become one of the most popular alternative energy source as it is cheap in installation and operation. Moreover, it do not require extensive maintenance as it does not employ many moving parts. The installation time of the solar farm is very short as well. China contributes to the maximum installed capacity growth in 2020, and she is also major producer and supplier of the solar modules. With this, solar energy plays a vital role in world's transition to sustainable energy future. With climate change being a major issue, humanity must act to replace all coal and gas generating stations by clean, green and sustainable energy. Thank you for watching this video. Please like and subscribe the channel.